Good day, everyone. We are now on the last topic or the last method of finding the particular solution of a second order linear differential equation with constant coefficient. This is the method of variation of parameters. So last time, I already had the discussion of the first three methods, which are the method of undetermined coefficients, the method by inspection, and the method of reduction of order. So for today, this is the last method of finding YP, the variation of parameters. Similar to the previous method, which is the reduction of order, we can use this method of variation of parameters if we know already the complementary function YC, which is again the solution of our homogeneous LDE with constant coefficient. Let me give you two sample problems to illustrate to you how to use this method of finding YP. And one of the methods is, or one of the sample problems is the sample problem that we had in the reduction of order discussion. Solve the equation d squared minus 1 times y is equal to e to the x plus 1. So again, the solution of this differential equation, sorry, our solution for this differential equation y is equal to yc plus yp. Let us solve first for yc. So yc d squared minus 1 times yc is equal to 0. And our auxiliary equation, m squared minus 1 is equal to 0. Therefore, m is equal to plus or minus 1. So therefore, our yc based on this uh, roots of the equation which are real and distinct would be equal to c1 e to the x plus c2 e to the negative x. Okay? So what is then our yp? So our yp will be based on this value of our yc. We will just be changing the arbitrary constant c1 and c2 to a and b. So we let our yp to be a e to the x plus b e to the negative x. Take note that a and b here are variables such that when you take its derivative, it should be a prime and b prime. So for our yp, from the given differential equation, you have d squared minus 1 times yp is equal to e to the x plus 1. So we have here already your yp that we have formed from our yc. Again, we just change C1 to A and C2 to B. So that is your YP, and our given differential equation calls for the second derivative of YP. So having this YP of A e to the x plus B e to the negative x, we now determine up to its second derivative. So the derivative of YP would be equal to what? That is A e to the x plus A prime e to the x minus b e to the negative x plus b prime e to the negative x. Before finding our second derivative, you need to impose a an equation for this. And the equation that you have to impose is actually the term that contains the derivative of a and b. And those terms to be equated to 0. That is imposing that let a prime e to the x plus b prime e to the negative x to be equal to 0. If these two terms will be equated to 0, then what would be our derivative of yp? The derivative of yp will now be a e to the x minus b e to the negative x. And with this derivative of yp, then we are to take our second derivative of yp. That is a e to the x plus a prime e to the x plus b e to the negative x minus b prime e to the negative x. So we now have your second derivative of yp and then your yp to be substituted to our given differential equation. So with the given differential equation, you have the second derivative of yp minus yp is equal to e to the x plus 1. So substituting what we had for the second derivative of yp and our yp, you have a e to the x plus a prime e to the x plus b e to the negative x minus b prime e to the negative x. And then you have minus yp. So minus a e to the x minus b e to the negative x is equal to e to the x plus 1. So simplifying, you have a e to the x minus a e to the x, b e to the negative x, and minus b e to the negative x. So remaining now on the left side of the equation are a prime e to the x minus b prime e to the negative x is equal to e to the x plus 1. Okay? And how do we find your a prime and your b prime? So having this equation that we imposed, let this be our equation 1 and let this be our equation 2. So solving for a prime and b prime using these two equations. So adding the two equation, you have here a prime e to the x plus b prime e to the negative x is equal to 0. This is your equation 1. Okay? So adding the 2, this is 0. And therefore, you have 2a prime e to the x is equal to e to the x plus 1. And therefore, what is a prime? A prime is equal to 1 half of e to the x plus 1 over e to the x. That is your a prime. So we can solve for a. And therefore, your a, so you have here your dA is equal to 1 half e to the x over e to the x is 1. And then you have 1 over e to the x. So that would be 1 half plus 1 half e to the negative x dx. And integrating both sides, you now have a. So a is equal to 1 half times x minus e to the negative x. Okay? So that is your value of a. And now we are to find the value of b. So using uh, our equation 2, we can solve for b or b prime first, and then we solve for b. or we may use the equation number 1 here. Okay, so 2, 1, this is your a prime, which is 1 half e to the x plus 1 over e to the x. So that is 1 half times e to the x plus 1 over e to the x. That is our a prime. We multiply it with e to the x and plus b prime e to the negative x is equal to 0. So we have now what is our b prime. So b prime e to the negative x is equal to 1 half of e to the x plus 1. Okay? And therefore, what is now our b prime? So our b prime is equal to, when we multiply both sides by e to the x, that would be 1 half times e to the x plus 1 times e to the x. Okay? And this is simply equal to 1 half e to the 2x plus e to the x. And now we find your b. So you have your db to be equal to 1 half times e to the 2x plus e to the x dx. And integrating both sides, we now have your b to be 1 fourth e to the 2x plus 1 half e to the x. Is that correct? Oh, wait. Here, we transpose it to the other side, so this is negative. Sorry. So this is negative, and therefore you have here negative, and this is also negative. Okay? So you have your b is negative 1 fourth e to the 2x minus 1 half e to the x. And since you have here your a to be 1 half times x minus e to the negative x, therefore what will be now our yp? So substituting to our yp here, therefore our yp, which is equal to a times e to the x plus b e to the negative x. In substituting, you have your yp to be a times, your a is 1 half times x minus e to the negative x 1 fourth e to the x plus 1 half. Okay? And then, simplifying, what is now your yp? So you have here your yp, to be equal to 1 half x e to the x. And then you have here minus 1 half and then another minus 1 half. So that is minus 1. And then you have here minus 1/4 e to the x. Minus 1/4 e to the x minus 1. And that is now your particular solution. And therefore, our complete solution for this differential equation is that you have your y, which is equal to your yc plus yp. Then therefore, y is equal to c1 e to the x plus c2 e to the negative x plus our yp, 1 half x e to the x minus 1/4 e to the x minus 1. And that is the complete solution of the differential equation. The quantity d squared minus 1 times y is equal to e to the x plus 1. Now we go to the next example that we had last time using reduction of order. D squared plus 1 times y is equal to secant x. So solving for yc first. So you have d squared plus 1 times yc is equal to 0. Our auxiliary equation, m squared plus 1 is equal to 0. Therefore, m is equal to plus or minus I. And our yc is c1 cosine x plus c2 sine x. And from this again, using variation of parameter, our yp would be equal to a cosine x plus b sine x. So for yp, you have d squared plus 1 times yp is equal to secant of x. So this is our yp. So let yp to be equal to a cosine x plus b sine x. And what we need again is up to the second derivative. So let us take the first derivative of yp. Derivative is negative a sine x plus a prime cosine x plus b cosine x plus b prime sine x. And now we are to impose the equation that let a prime cosine of x plus b prime sine of x to be equal to 0. And let this be again our equation 1. So with that, what is remaining in our first derivative of yp? So you have negative a sine of x plus b cosine of x. And we now to take the second derivative of yp. So you have here negative a cosine x minus a prime sine of x minus b sine of x plus b prime cosine of x. And we now substitute this to our given differential equation. We have the second derivative of yp plus yp is equal to secant of x. So substituting our second derivative of yp, you have negative a cosine x minus a prime sine x minus b sine of x plus b prime cosine x. And then plus yp. This is our yp. So let me put it here. Plus a cosine x and then plus b sine of x. Okay, and this would be equal to secant of x. And simplifying, so this is 0 and this is also 0. And remaining now, you have negative a prime sine of x plus b prime cosine of x is equal to secant of x. And let this be your equation 2. So we are now to find your a prime and b prime from equation 1 and 2. So let us have equation 1, which is a prime cosine of x plus b prime sine of x to be equal to 0. This is your equation number 1. Okay? So from 1, we can have here your a prime to be equal to negative of b prime sine x over cosine x. And we substitute this to 2. So you have negative of negative b prime. So you have b prime sine squared of x over cosine x plus b prime cosine x is equal to secant of x. Okay? Now, how do we find your b prime? Secant x, take note, is also 1 over cosine. So when we multiply both sides of the equation by cosine x, you have b prime sine squared x plus b prime cosine squared x is equal to 1. So you have here b prime sine squared x plus cosine squared x is equal to 1 and this is equal to 1. So b prime is equal to 1, therefore db is equal to dx and therefore b is equal to x. When you integrate both sides of the equation. Okay, and with that, we substitute from this equation your a prime. Okay, what is then now your a prime? So your a prime is equal to negative b prime sine x over cosine x. And with this, your b prime is 1. So your a prime is equal to negative sine x over cosine x, or your dA is equal to negative sine x over cosine x dx. Then you integrate both sides of the equation. And therefore, what is A? A is ln of cosine x. Okay? And therefore, you have now your A and you have your B. Therefore, our YP which is equal to A cosine x plus B sine x. Therefore, your YP is equal to cosine x ln of cosine x plus x sine x. And therefore, our y, which is equal to yc plus yp, your y is equal to c1 cosine x plus c2 sine x plus our yp, which is cosine x ln of cosine x plus x sine x. And that is now the complete solution of the given differential equation. So if you recall, this is the same solution that we had when we use your method of reduction of order in our previous discussion. So again, remember that in variation of parameter, we can apply this if we know your YC. And we will apply only in this class the second order differential equation. We are just to vary the parameter, our arbitrary constants from the complementary function. We are to vary it to a new parameters A and B. And after that, we take its derivative and you impose a differential, an equation such that that equation consists of the terms with the derivative of those new parameters A and B. So the term with the A prime and B prime to be equated to 0. Then you simplify and then you take its second derivative. After finding the second derivative, then you substitute them to the given differential equation and then um, take the necessary equations to find the unknowns A prime and B prime and later to find the values of the parameters A and B. And with that values of A and B, you will have the particular solution. And having the general solution of YC plus YP, then you will obtain the complete solution of the given second order differential equation with constant coefficient, which is said to be linear differential equation, non-homogeneous linear differential equation of the second order. So I hope that with this two example problems, you learn something and you will know how to solve or to find YP using the method of variation of parameters. So you may try the other sample problem that we had in reduction of order using the method of variation of parameter for finding YP. Thank you.